As global temperatures rise and the world sees more episodes of extreme weather, adaptation to climate change and a more efficient use of natural resources is increasingly necessary. Landfill sites are infrastructures vulnerable to the impacts of climate change. Extreme weather, including heavy rain, means an increased risk of flooding, which can destabilize landfill sites and cause environmental pollution. Heat waves and droughts also mean an increased risk of landfill fires, explosions and reduced water availability for use at the landfill site. Life Green Adapt aims to increase the resilience of landfill infrastructure against the impacts of climate change by implementing nature-based solutions to mitigate the impacts of extreme weather and promote circular economy. Nature-based solutions take inspiration from nature, integrating water and vegetation-based design to provide a network of natural and semi-natural areas to be able to make the landfill site more resilient to the effects of climate change. Life Green Adapt uses an industrial demonstration site in As Samotas, Galicia, Spain, to test and demonstrate the validity of the nature-based solutions under a real-scale landfill scenario. The first part of the process is the design and implementation of biotechnosoils. These novel biotechnosoils are used to stabilise, recover and increase the soil quality. This prevents landslides on the landfill site caused by extreme rain and floods. The biotechnosoils are made of different wastes from the landfill. The reuse of materials increases the sustainability of the biotechnosoils. The first of the liquid waste streams generated, the landfill leachate. The liquid that drains from landfill sites is treated using a two-stage nature-based infrastructure approach. First, the leachate runoff passes through a floating treatment wetland, which is used to store and pre-treat the leachate. After this pre-treatment, the liquid waste is treated by an aerated vertical flow treatment wetland. This wetland uses a geopolymer in the filter bed made from metakaolin waste. This is an industrial byproduct, so reusing it in the wetland increases the sustainability of the Life Green Adapt process. Treated water that has passed through these two types of wetlands reaches sufficient quality to be reused on the landfill site, helping to manage and boost water resources in times of drought. The second liquid waste stream, the stormwater runoff, is stored and then treated using a novel electroactive biofilm-based treatment wetland. Central to this type of wetland design are electroactive bacteria, which facilitate the transfer of electrons to a bed of electroconductive material, increasing its pollutant treatment capabilities. The result is a water effluent that is suitable for environmental discharge or for reuse in landfill irrigation based on the reduction of pollutants achieved. What are the results the project expects? Firstly, Life Green Adapt will avoid the spillover of polluted waters, increasing resilience to flooding. Secondly, there will be increased water availability to use on site. This water can be used to decrease the landfill temperature and increase resilience to droughts and spontaneous fires. Thirdly, there will be a reduction in the carbon footprint of the landfill site by implementing this Life Green Adapt process. The Life Green Adapt project is designed to be replicable and transferable. The project supports the transition to a climate resource efficient and low carbon circular economy.